All right. I guess while the last attendees are coming into the lecture hall, let's start this data science seminar on the topic of AI for software engineering. My name is Dietmar Pfahl. I'm a professor of software engineering here at the University of Tartu. And I'm very happy that Jagvilu, who is basically the organizer of this whole series of data science seminars, asked me to have a session on a software engineering related topic. But why have this seminar anyways? And I think, we all know that AI is taking the world by storm, but it is also taking software development by storm. And one of the, let's say, the questions is, what do we as teachers in the university know about how industry is doing software engineering now with the help of AI? And that's, I think, why I wanted to have this seminar. And I'm very happy to have a set of very distinguished speakers here. I think you will soon be seeing the schedule of the event with all the names, but I know almost all of them for 10 years or longer. There's one new acquaintance also here. And I'm hoping that we will learn a little bit more from them about what they do in the companies. So you see we have 3 speakers before the coffee break. Actually, just before the coffee break, there will be also a small announcement related to our what we used to call Industry Master Program. Now it has changed the name. I forgot. Digilink, I think it's called. And then we have coffee break outside as now. And then after the coffee break, we continue with two additional speakers. And then we have a small panel session where I would like to gather all the speakers and we can have discussion. Of course, the audience is also invited to ask questions, actually also after every speaker. So speakers are supposed to talk 15 minutes, more or less, and then we have a small question-answer session, and then after that comes the next speaker. And I think this now, and of course, at the end of the event, there's also a networking session, so there will still be outside in the foyer, there will be drinks and some food and so on. So now let's get started. So Priit, Liivak, please come to the stage. And I think you're already set up with everything. So once yes. You're here, you can...
I just need the clicker.
Right. Okay.
Awesome.
Thank you.
Thank you. So thank you for the invite. It's a pleasure to be here. As said, my name is Priit Liivak. My current role is Chief Government Technology Officer at Nortal. I have carried the roles of Chief Architect and Software Engineer in the past, worked with numerous teams in Estonia and globally. Been with the company for 19 plus years, so have seen it evolve quite a bit. In addition to that, I'm also hosting one of the Estonian most famous Estonian-speaking software engineering-themed podcast called Artem, that I have been running over 6 years now, and through there I've had over 300 interesting conversations with our industry leads as well as specialists who recently are talking more and more about AI, surprisingly. So today I wanted to talk about some of the observations and patterns that I've noticed in the mindsets of successful teams and teams that are struggling to maybe something others can learn from that relate to the adoption of AI in software engineering. So these are not all Nortal stories. These are from the podcast episodes. I highly recommend you to go there as well because some of those episodes have been really insightful and provide quite a bit of lessons as well. So to begin with, what I've seen and observed is that motivation for teams to adopt AI for software engineering is very different. And the motivation, the source of motivation matters a lot. One of the repeating patterns is with different startups who might have their backs against the wall, so they are kind of forced to be more efficient, to deliver faster and potentially better results. So in that situation, they are in a place where they need to change to remain in existence as a team or as an organization. And those teams have the highest motivation to change, so they're willing to change everything, starting from their processes, the tools that they are using, the architecture of their software, but also team composition. They're open to the idea that we might cut the team in half or change the roles entirely. And this is, in terms of AI adoption, this is kind of a luxury in a way, because in many other organizations, teams are in much more comfortable and safe space and place. So they don't have this sort of driving force behind them that forces them to change everything. And what I'm also seeing is that in organizations where this AI adoption is done in a very voluntary basis, out of free time, so there is kind of a permit, or you can use AI for software engineering, but there is no push, there is no leadership kind of initiative that please start using AI now, or any objective for the team to adopt AI, then these adoptions are not thorough enough. So they don't, if there's one person who's really enthusiastic about AI and is experimenting on the side, it is really difficult for that person to change team composition or entire ways of working for that project. So it is important to understand, do we know what pushes us to change? Why this team should adopt and wants to adopt AI? And there has to be consensus across the entire team for that. So another thing that, another kind of pattern that I've seen is about expectations. So many teams have an expectation that AI is kind of like a tool that we adopt. So we start using it, we become 10x engineers, and Bob's your uncle. So but it's not like that. There is no switch to just turn on AI. And the AI adoption, just as pretty much anything in good software engineering, is a process of growth. So it's a process of change where you start off small and then you transform into something different and something unique. And oftentimes where teams start with is with AI-assisted code reviews and engineers building with AI synchronously. And when I'm saying with synchronous agents, I mean here that they are sending out a prompt to some agent and then sitting there and waiting for the response to come back, and then reviewing the outcome and working with an AI agent in a very synchronous manner. The usual kind of follow-up evolution step is asynchronous autonomous agents. So where already maybe the changes are triggered by Git commits, that I change documentation and requirements in a repository, and there's numerous agents on the background that create new feature branches on top of that and start implementing, deploying, and so on. Then we get to the next stage of evolution where we already need a platform team, essentially, that maintains all that machinery within an organization or within that project. And that opens up an opportunity that we potentially can even open up the use of AI for our customers or power users who might request new features and then see them deployed automatically in a test environment. And then potentially the last step is about embedding this functionality right within the application. It was already 10 years ago when pretty much every application we built contained this feature that if you want to change any labels or kind of static text within the application. Some power user just enabled the feature, and each label had a small icon next to that so that they can open up a pop-up and modify the labels in each and every language that the translation was in. Nowadays, we don't need such features because many applications are automatically translated anyway. But I'm envisioning that in the future, we're going to have AI agentic prompts embedded within the application in this way, so that you can provide context to the agentic developer immediately from within the application. So a power user can open up a page, and right next to the submit button, they can say that next to this button, I want the save draft button, and this button should do something else. But this already requires a lot of kind of machinery on the back end to make it work. And that machinery should first evaluate if there's sufficient input to start engineering, if this is something that requires additional validation from software engineers. Is it a kind of minor change, or does it require architectural change on the background? What agents should be involved in building such a solution? So you can imagine that this is a point where every team wants to get to, but you don't get there like that. You can't just flip on AI. So my last kind of observation is about the role of software engineers. And there's a lot of discussion how this role changes. In my mind, it doesn't change too much. So usually, before, software engineers were writing code that delivered business value. But now they're building factories that write code that deliver business value. So they're still designing systems, but these systems are just doing a different thing. So they are building systems that design and build business systems. But to do that, you need to follow the same process design and system design principles that engineers have learned and used for a long time. So if we think about some of the large language model applications that are out there for software engineering, where you just put in a couple of prompts and you get full and complete application out, then this is a system where you just have, this is a greenhouse where you just have one input. You just post everything in there, how to water plants and how to kind of add fertilizer and what is ready to come out from the other end. And this is not sufficient for gardening, and this is not sufficient for software engineering as well. This is something that works really well for building POCs, the proof of concepts, but it's not something that sustains you for a long period of time. And as soon as you start building something really complex, you need to follow the same process design and system engineering principles that we have done for a long time. So systems that are built, that build other systems, also need to have observability, maintainability built in, so that whenever within this process you see that the outcome doesn't meet your expectations, you can identify the exact point. Is it the planning? Is it the creation of technical design where this thing fails? And you can refine that specific segment within that factory that effectively helps you improve the entire factory. But these principles carry over to the designing of these agentic AI systems, just as they were present in designing regular systems. So successful teams, we see, know and understand what pushes them, what drives them, what's the motivation behind them, and this kind of provides them information. What are they willing to change? Are you willing to kind of put away your position in this team in this organization to make AI work? Or can we change entirely the ways of working, kind of transitioning individuals' roles and quality assurance kind of steps that we have come used to over the years? There is a necessity to invest constantly into improvement, so it takes time. You start small at some point, put in effort every week to do small change towards this more complex agentic system, and you eventually get there, but it takes time. And this is also a mindset shift for not only leaders, but also for engineers who are part of this process, that they need to take it slow. And following good principles to be efficient. I think this is the most crucial part, having the understanding how it is more difficult to understand one big black box than 10 smaller black boxes, and to debug like what went wrong with this code review result, rather than like why doesn't this application work like it should? Because otherwise, if we don't follow these principles, we're going to end up some sort of large AI monster that nobody wants to maintain, and it's going to be difficult for you to get new people on your team and work on that. Because eventually somebody has to continue working on that. Adopting new technologies and ways of working might be fun and interesting, but at some point that AI machinery is going to be legacy as well, and you want that to be of good quality so people can take it over and continue maintaining and developing it. So thank you. That's all from my side. Do we have any questions from the audience? Yes, this.
I didn't see. Is there somebody? Yeah, okay, yes.
Thank you. There must be huge differences when your teams develop some product for yourselves or for the customer, where the code is actually that you deliver with all the responsibilities. How do you approach these copyright issues of the code and or patent infringements in code? Do you ever worry about that, especially now in automated coding?
It is very crucial to understand the licensing terms of all of these products that are used, and most of the times the free tier doesn't cut it. In most cases, you go to a higher tier, and then you can pretty much relinquish some of the responsibility towards that service provider. So if something leaks, it's their responsibility to the contractual agreements that you have with them. But in terms of building big systems for customers, the same problems are faced when need to be communicated with customers as well. So why are we using AI in this customer project? What's the motivation for that? And the expectation management. There are many customers who come in and say, we want to transition our project to be AI enabled, and they expect it to happen immediately. They don't understand that it's a growth process. In terms of copyright, I don't think it's very much different than for regular software engineering. We need to take care of the IP rights and take care that it doesn't leak. And having proper licenses with the tools that we use helps us to safeguard that. There's one at the back.
Thank you. So in your day-to-day operations in Nortal, where would you say that you actually are on that roadmap from code reviews, doing AI, and ending up with these agentic platforms?
It's very different from team to team, but like pretty much all teams are above the starting point. They're beyond that. We also have a specialized R&D driven kind of a tiger team that helps teams to adopt and adopt new technologies, so to speak. So become more agentic in the use of AI. I wouldn't say no team is pretty much at the last step where you can hand over an AI agent to a customer and say that like you can ask anything. It will deploy to a new test environment. You can try it out immediately. Then it will go to an automated code review. And finally, maybe software engineer just ticks a box and it's in production. So we don't have those teams, but we're definitely moving to that direction with some of the projects.
And do you have any estimates, like how big are your productivity gains, for example?
The productivity gains are between 20 to 70%, depending on the depth of adoption. So there's no team that's delivering twice as fast, but 1.7 times is a really good result already.
I do have actually even 2 questions, but I would like to save them for the panel because I want to ask them to all speakers.
Okay.
But is there any other question? I mean, as I said, there's later also a chance during the panel, but if not, because then I think we can indeed move on to the next speaker. So thank you again, Priit.
Thank you.
Yes, Artem, please, from Swedbank.
Sound check? Okay. Hello, everyone. My name is Artem, and I work as a data scientist. You probably can guess where. And I graduated this university 8 years ago, a Master of Software Engineering. So very happy to be here again. And today I'm going to talk about how generative AI assistance feeds and transforms the software team culture. If you got the scikit-learn panel in the title, talk to me afterwards. We have a position open. But spare tire or steering wheel or something in between. What is the AI role in this? Let's explore together. Yes, so maybe a bit of context about my team. I work in Group AI Accelerator, a team in Swedbank, which is responsible for AI adoption for basically the rest of the bank. The small team I work directly in, it's about 8 engineers, 6 data scientists, 2 infrastructure engineers. And of course, we would like to use our products ourselves, so to accelerate ourselves. But we also don't want to overcommit towards this new AI thing, because it's a bank, and if I told you that the whole bank is vibe coding, then the stocks would crash, right? So, but we're not vibe coding, I promise. I have to talk to HR about that. But anyway, this is what I'm here to talk to you about, how we use this AI. And I came up with this chart, which I call a speedometer. It's very similar in spirit to what Priit has showed in his talk before. But while Priit's was like a natural transition from one state to another, I have heard this speedometer metaphor, and I think it's very appropriate because you decide where your team is, and also you don't want to be too slow because you won't get anywhere and everyone will bypass you on the lane. But if you go too fast, you'll crash and burn. So let's maybe take a look a bit more on the individual steps on this speedometer. I would say, from my experience watching teams adopt AI, the first stage is what I call spare tire here. Teams copy-paste code from ChatGPT on an ad hoc basis. Usually it's kind of a last resort when it's a very tough problem or frustrating thing, and or maybe very tedious task. You go to ChatGPT, you type in something in. We've all done that. Usually at this stage, teams struggle, at least in the big organization scale. It's not a problem for startups, but in big organization scale, there are struggles with privacy restrictions. Like, are we allowed to copy-paste our code? Probably, but what are the copyright considerations to already into the training sets of big AI companies? What if there are some kind of internal architecture? Isn't that a security leak? So usually these kind of questions teams struggle with, and they go to the privacy managers and try to solve. But there are some teams, I would think, is still staying at that level of kind of AI as a backup solution, as a spare tire, and I think that's totally fine for that context. Next stage is usually training wheels, where this is where people are using IDE AI plugins to speed up mostly low-level code development. Write me this particular function by the description, or generate documentation for this function. Some boilerplate automation of templates, of tedious tasks, of documentation, but the care is being set for not kind of putting anything mission critical in there, because again, privacy restrictions, and also we don't want to crash and burn, as I mentioned. So it's a risk management thing. And talking about risk management, we arrived to the next level, I call gearbox. For those of you who have never seen the manual cars, okay, I'm just joking. You know what the gearbox is, right? It's when you switch the speeds in the car. And similarly, this is also when you are taking decisions, and AI is often assisting with these decisions. But it is also your decision whether to apply AI or not for a particular purpose, right? Usually at this stage, we consider the more sensitive areas to apply AI, especially like if it's a pipeline, if it's something exposed to a client, or maybe something working with confidential data, or maybe something, a lot of things we work on are being worked on on a server isolated from the internet, so using online AI is not really a choice there, so we could only use on-prem models. But it's kind of this balancing thing, and personally, my team is currently in between training wheels and gearbox. We are transitioning to this gearbox, and this is where we want to be. We don't want to go any faster, at least with the current AI capabilities. And yeah, also another indicator of this stage of the gearbox is at the training wheels, everyone probably first wrote the prompts for themselves and kept their own documentation. But as we arrive to this stage, there is a shared prompt knowledge base and a shared agents.markdown in the repository, which is like this file guiding the software agent. We are trying to collaborate on that and basically make sure that AI is productive enough or on the same page for everyone. And the most important thing about these levels on the speedometer is it doesn't really matter which level is your team on. What matters is everyone in your team is on the same level. So there is no like wipe coder person who is completely out of that and everything, and then the rest of the people are doing everything by hand. You have to be aligned. You have to collaborate. Otherwise, it's going to be human conflict or human versus AI conflict, but we'll get to that hopefully, or not. The next step is cruise control, right? When you put the pedal down and the pedal is driving itself. Cruise control, CC for short. You know what else is CC? Cloud code, right? So it's in many ways, or that, or Cloud Cowork is also there. But Cloud Code is going through a very much hype period right now, and especially if you're on Twitter like me. And basically, it's if your team is adopting the cruise control mindset, you understand that AI participates in not only in like lower-level coding tasks, but already in planning, coding, and review tasks, at least as a peer human with you. And then the final step to be is steering wheel, full-on vibe coding. I won't be elaborating too much here because I don't believe in a big company you have to work this way, but there is something liberating of doing it on the weekend when you just describe what you want and basically just criticize, right? But yeah, and of course, I'm not covering technical parts of the process. I don't have time for that. But I'll cover a bit on how does this speedometer affect our team decisions. How do we feed AI in our processes on this gearbox level? So here are our key principles. We are working with GPT models, usually provided by ChatGPT or Copilot, because that's what our organization does. So the first principle is full transparency and even shared chat traces sometimes. We don't do something via AI and then we don't go to our team and say, I did this. We say, my friend Copilot did this. While I'm here, I want to say my thanks for GPT 5.2 for helping me prepare the slides for the presentation, but the insights are all my own. Next principle is only a human versus full responsibility for a decision. Or be it an email, or be it a pull request or a message, whatever you submitted, it is you who are responsible for that. If there are flaws in that, you cannot say, oh, the AI did this. You have to say, oh, I did this by missing that, by not reviewing this carefully enough. Next thing is, of course, unit tests. They are doubly as important as before, and they were really important now already. But tests are the direct line to requirements. And requirements is what are you trying to do for the business problem, right? So by using tests, you can go TDD, you can not go TDD, but make sure that the tests are there, not just unit tests, but integration tests as well, and they are covering the whole functionality. And at least spend some tokens on this, okay? No, don't let the code, don't leave it untested. And I mentioned a link to requirements. And requirements in a business context usually happen through requirements iteration loop. When the business comes to you and says, we want to do this, and then you kind of trying to clarify that, maybe through building some prototypes and demos, and it turns out that what they really want is not this, but a very different thing. Include AI in this process as well. It could be just that it will help you structure things down from simple meetings and break down a bit how it works. And it could be that there is some contradiction which the AI will catch for you. So I think this is what the indicator of this gearbox level, the golden middle ground, is that AI helps not only with the code, but also with requirements as well. And clean context window is better than a bloated context window. I know we are not the most advanced on this here on this speedometer, and I know for agentic workflows there are a lot of techniques of context compacting and basically some automatic summarization. But for simple things, like using ad hoc chats and using basically loops for engineering something, we find that starting new chats and new interactions with summarized information is better than trying to fit everything into the context window, even if the company advertises 128,000 tokens, and we are not feeling that. Still, there is LLM still better with smaller context and larger contexts in our experience. We have always practiced 4 ICE principles for code reviews, meaning 2 humans review every pull request. We are in the early stages of experimenting with AI review process. We trust AI more as a coder than as a reviewer, actually. But still, this is very important to keep going with. And that doesn't actually include the person who has presented the pull request. So it's actually 6I principle. The author may be in co-authorship with the AI, and then 2 more colleagues to review. And then, of course, updating documentation allows you to apply what you have learned, maybe after some post-mortems, some analysis to the new project. And after following these principles, we turned out that actually our principles are getting transformed by generative AI use as well. We had a set of documentation called coding conventions internally, which were basically the best case, which were the things which we were following to keep our context standards high and on the same level. And before it was this kind of different repository, and we didn't update it very frequently. Here we found that agents.md has become a hub for all of the best practices. So we try for AI Assistant to maintain here a list of all of the tool stacks we are expected to use, whether it's packaging or testing or a linter format or whatever. The coding principles we try to follow and adhere to. The style preferences and style nitpicks, descriptions of CI/CD pipelines, because we have those continuous integration and delivery to validate that our coding conventions are being followed, and the agent having access to the descriptions means that it can plan for passing those. And all non-functional requirements are also, we try to cover there what is our level of latency throughput, so that the agent can reason whether the application is compliant or not, and plan some testing around that. And also, we've discovered that that documentation slowly migrated to the same repository as the code is. So it lives in agent.markdown, and it's closer to the code there, meaning that it's a very easy task to edit that. And another thing we are using in addition to agents.markdown is architecture.markdown. It's also kind of a standard. You can read it up about online. But basically, it's a description of architectural design of the solution. And actually, in Swedbank, we distinguish between architecture and design for software. A software design is something you can, which directly describes your applications, components, whether you have modules or microservices, how they interact with each other, what's the flow of execution, what's the flow of data, what the validations, etc., etc. And architecture is more about how does this integrates in a broader context of other systems in the bank. How is it deployed? How is it monitored? How does it get input data, output data, integration with front end, security, maybe some authentication walls, all of that. And usually there is a big edge and a big source of friction in between design and architecture, which usually goes like this. First, the team writes a quick prototype by its own design, and then we have to adapt to the kind of top-down architectural requirements. And it's whole process from prototype to production, which might be more complicated than the actual solution we are writing. And here, AI helps kind of maintain those architectural requirements, and the design requirements keep that in sync. And as long as you give it the necessary architectural description documents and basically the golden standard for other projects of this case in the bank, then it will keep that in mind while designing, and it becomes a more frictionless process. Yes, I think this is it. So please, questions.
Thank you. What is your experience? How well are the agents and models following the architecture description you give them, and also all the guidelines? Like, do they forget it sometimes, or are they always following it?
Mm-hmm. Yes, good question. Yeah, this is one of the reasons why we are not higher on the speedometer yet. One thing is the context requirements, of course, but the other thing, in practice, there is some kind of internal attention limit where it sometimes drops some of the requirements, but the solution for that is, of course, loops and basically a second validator agent. We have not yet fully resolved it. It's a very fresh thing, fresh transformation we are going through. So, but I think it is something to keep in mind, especially if the models are not top line.
Okay, thank you. I asked it because I have been trying dynamically loading instructions. If I'm doing something specific, it will load instructions for that, not the entire architecture always and stuff like that.
Mm-hmm.
So
yeah, I think maybe some reg-related patterns might be more useful than just dumping them into the context, because those can get very wordy.
Thank you. You said that it's recent. Can you elaborate how recent? Did you think about that last spring, last September,
Yeah,
December? How recent things you are talking about, the transformation within the bank?
Yes, so the unit I'm working in, these group AI accelerations, have been formed spring 2024, and yes. And this kind of software transformation we are going right now, it's basically going as we speak. Maybe a couple of months ago, we only started thinking of this agentic AI-powered software development flow. On the time scale of month, yes. It was, of course, we have some more experienced people who have been doing it maybe for a year or two. And of course, we are an AI team, so we are all familiar with this. But we only started doing it systematically and like on a team agreement level, only for a month.
Thank you for your presentation. You have mentioned Copilot and ChatGPT. Do you have any preferences, or maybe one model is better for task A and another model for task B?
Yeah, but Copilot is actually using GPT line models under the hood. So it's mostly depending on what are you using it for. We have used GitHub Copilot for the code, powered by, well, GPT-5 most recently. And I think GitHub Copilot generally is kind of better for these low-level tasks, but ChatGPT is it works better with kind of the documentation in multiple formats. If it's like usually in bank you have to work with Word documents, PowerPoints, PDFs, these kind of things.
Mr.
Yes. Do you also use AI for code testing? And if you do, then how?
Right. I should have mentioned that during the presentation. Our main principle, I would say, is we don't, at least at the gearbox stage, there are two stages: writing code, testing code, and reviewing code. We don't let the AI do all three, and we don't actually try to not to do 2 out of 3. So we do employ AI tests for human written code, and we do employ human tests for AI written code. But if the AI writes this code and if AI reviews the code, then it's even if you do different agents with different prompts, etc., it's still the same baseline data distribution under the hood in the LLM. It has the same biases, and it's likely to miss something critical.
Okay. Anywhere a hand? No? Okay. So I guess since we have a little bit, a few more minutes, I can, and since I'm a professor, I can also ask a stupid question.
Please.
You studied software engineering.
Yeah.
Your degree is Master of Software, but your role title now in the company is data scientist.
It is.
Was it useful to study software engineering to become a data scientist?
No, but very much. I think the year I started here, was the first year the data science program was established. And it was very useful because what I do on my role, on my daily work, has shifted a lot during the years. In my early years in the bank, it was a lot of classical data science, machine learning. But then we ended up in a situation when we have 100 ML models trained, weight saved in a pickle file, and now it is in production. So we need engineering capacity. So I kind of low-key transitioned into the software engineering role, and I think that is kind of the main thing I am doing right now. But the top 20% of my work is data science, and this is where I apply my wisdom about how to do things, to do the normal software engineering work a bit more clever and maybe a bit more data-driven.
Thank you very much. And I believe Marina is not yet. So we maybe almost. So is there still some?
You did not mention data engineering.
Yeah, I did not mention data engineering, of course. Thank you, Professor. We are kind of a grab bag role in there that we do data engineering. And indeed, it is a huge part of the workflow because our team specializes with working on unstructured data. So things like chunking a PDF document or extracting some fields is a lot of things that we do, not to mention data source thing with a myriad different complicated systems in the bank. But usually we do some external support for that.
Priit, so
So do you also have any technique or approach how you choose where to adopt or use AI? You mentioned many places like doing business documentation, code, and so on. I know some teams have a principle that for every problem we try it with AI. When it doesn't work, then we think what we can change, then we try again with AI, and then we do it manually or the old way. Do you have any principle of like that?
Yeah, thank you. The principle you referred to is essentially what I described as cruise control, right? That we start, AI is the default, and then we try to kind of layer things on top of that. In our case, we are a bit more conservative than that. We try kind of more of a risk-based approach, meaning that we default to AI if it's if the cost of failure is not that high, and if it's like an early prototyping model, and if we are experimenting, then we can go all in of AI. But let's say it's a production model or a production app, and we have to build a feature on top, and then AI gives this huge and 1,000 line of code which we have to untangle, when that's where we would probably go human first and lean of AI as a crutch.
Thank you.
So I think we are now ready for the switch. So thank you very much again.
Thank you.
I guess you introduce yourself, right? You will do it. No, you will introduce.
I will introduce. Okay. Yeah. My name is Marina, and this talk will be different because I'm working at university, and I'm teaching programming, so I do not anything about, or I do not know much about really software engineers work, but I am teaching programming and mostly basic programming. So I'm teaching programming for already 20 years here at the University of Tartu. I'm teaching different programming languages, Python, Java mostly, and for different student groups and different formats, e-courses, MOOCs. Programmeerimisest maalahedaselt is a very popular MOOC for everyone, for example. And for different students as well. So we have computer science students, but we have all other students as well. And today I named my talk at the Learning Vibe with AI, but actually it will be about how our students use and perceive AI, and how they perform in programming after their learning using AI. So I will talk about one my course. This is object-oriented programming course. This is second programming course for computer science students. And this is in Java, but our first programming course is in Python. This course is compulsory for all our computer science students, but are also very popular among others. 16 weeks, usually as always at the universities. And we use a flipped classroom approach. This means that students first should learn at home. They watch videos, and then after that they have to solve some homework at home, and only after that they will come to my class, and we will this is like active learning part. We will discuss and solve some more difficult exercises. And after this AI, we added we definitely should have some policy for AI, And for this course, policy is that it's allowed to use for homework and projects, because we cannot ban, and as I think that does not, we do not need to ban AI, but as this is basic course and we want students to learn something about programming, then we do not allow to use AI during programming tests and exams. And just for clarification that I'm talking about AI, but actually as students using only generative AI tools for this course. So this will be, my AI is only conversational chatbots like ChatGPT or Copilot, and this integrated coding assistants that they can use in their environments. So, as a teacher, after my students using AI, I wanted to know how actually students use AI tools, how helpful they perceive these tools to be, and what are attitudes towards AI, and how this AI use relates to performance. And for answering these questions, so as I cannot check what actually students do, I asked students to write me to answer my questions. So usually I'm asking for feedback mid-semester. We have questionnaire survey for students, and 2 years ago I have added questions about AI. So there are different questions, multiple choice questions and open-ended questions as well. We have more than 300 students every year, and more than 200 students answered to survey. And we use different methods for analysis, like Spearman correlation and inductive thematic analysis for open-ended answers. So let's start with usage. I asked specifically how much they use AI for this course, not at all, but especially for the course, because maybe they are using for something else. Here it's only for the course. So 20%, 2 years ago, 20% of students answered that they never used AI for this course. So this means 80% of students used AI at least once. Then I asked, so how much they have used. And so almost half of students actually used the AI only occasionally, so only just once or a few times. And only 5% of students used AI weekly. Last year, I asked the same question. You can see the change. It's not very big, but still. So last year, only 12% of students never used AI, and almost 90% used. So still we have 40% of students that used AI just once or a few times, and only 9% that used weekly. So for those students who answered that they did not use AI, I asked some questions, why they do not use AI. They do not have to use, but why? So the most popular answer was that I want to think independently, to solve by my head. I do not want to use additional help for learning. Some students that they were afraid of that it will not be clear, these topics. And only 15% of students were afraid of plagiarism. Then the students had the opportunity to comment more specifically why they do not use AI. And it was because some students think that traditional resources like official documentation or friends are more suitable for learning. Then I like these answers because materials are very good for this course. They do not need to use AI where learning and topics are understandable. Of course, this independent learning was mentioned again, and there were a few concerns about plagiarism and about long-term learning. They tried to use AI for the first programming course, but then they discovered that they actually did not learn, did not know enough to pass the exam. So as my course is the second one, they already thought that they will not use AI for learning. And I actually, this is interesting that they do not have time to use AI, but as it was a survey, I did not have opportunity to ask more from the students, so what does it mean? So they do not have time to use AI. But it was mentioned as one of the reasons. So from this, who used AI, I asked what tools they are using. And as you can see, ChatGPT is most popular tool. Also DeepSeek and Gemini, and some integrated assistants like JetBrain AI assistants and full-line code completion. This is all tools that they have mentioned. They have opportunity to add tools in addition, and some were added, but this is all tools that were mentioned by students. So then I asked for what tasks or parts they are using AI, and of course the most popular answer was homework. Programming tests were mentioned or were selected as well, but they cannot use during the test. They can use only preparing for the test. And group projects. And how they use these ways of use. So debugging is the most popular answer. Then asking for explanation and getting ideas. So it seems that generating solutions is the least popular answer. So it seems that students are using AI more than tutor than answer generator. I hope this is like this, but this is students' answers. And the students could comment on the ways of using AI, and here only some interesting answers. As this course in Java and first course in Python, so students were using AI to translate Python code to Java, which may be very useful for them during the first weeks. So they are also using AI to discuss how to solve, how to think, and how to simplify the exercise, so to solve step by step. Also for translating just language, if it's Estonian, it's not native language, then to help to understand for this exercise. To generate data for projects, and to generate some simple code snippets like assigning variables. So, okay, they're using AI, but how much AI is helping them? So it seems that AI is very helpful. Only one student answered that no help at all. And half of students answered that it's enough help or always helped. And what they like about AI, of course, it's very fast. It's available anytime. It's possible to ask questions without judgment, even stupid questions. It can be like a private teacher to students. It explains, it shows or gives examples, clarifications. It helps to see another view. It finds errors in the code. And this is my favorite. There is no ads and pop-ups asking about cookie usage. It's very important for students. But dislike, so of course there are mistakes in the code. There can be different mistakes, logical mistakes, and some syntax mistakes. This process needs additional, or these answers need additional fact-checking, which takes time. Then this solution can be complicated, and actually this is good, as I'm as teacher can see that the student using AI if these programs are very complicated and using techniques that we are not teaching. But for students, it's very bad. It's complicated answers. Sometimes AI does not understand what exactly I want, and it sometimes change something. It's hard to follow. And this is concern about thinking less if using AI. So AI can get stuck. And the better models cost money. So this is, students like something, but dislike as well. So we wanted to check some attitudes as well. So this was some statements, and the students had to agree or disagree with this statement. For us, it was good the students first checked materials before using AI. And this was surprising that students still struggled with homework, even if AI can find the mistakes and explain everything. And this answer about teaching for help, asking for help from teaching assistants. So it seems like some students prefer to ask, and some students just prefer to ask AI. Last year we asked also for some more general statements or questions. And here we can see that actually answers very broad. So we have students who agreed and students who disagreed. But some interesting that this over-reliance, it's still like more students agreed with this, that they concerned that they will become over-reliant. And then they do not trust the code. This is good, maybe. A little bit concerning for us that almost 1/3 of students have rule-bending attitudes that they would use even if we disallow, or even that if other use or something like that. And the last interesting is this about our abilities to detect code. So students are uncertain, can we detect code or cannot? And about performance. So 80 or 90% of students had used AI. And then we have different programming tests and exam. And this analysis showed that more students use AI, they will have lower scores on tests and exams. But we actually also find that more frequent AI use correlates with perceived difficulty of homework. So this seems that weaker students use AI more, which is quite logical. But still, it's can be that that it's in another way that they used more and then they had lower scores. It can be both ways because we used only this data that we had that we have to investigate more. And so we do not have questions whether to use or whether students should use AI, but how to use AI, how to integrate AI into our teaching and learning as not replacement for learning, but as a supplementary tool. We have structured guidelines, so we have we hope that we have still to teach students to know code, to know how to program, not only to use AI. And as we have seen, so we have to provide targeted support for weaker students. So if we come back to this learning vibe with AI, it seems that using AI is helping. It's learning easier. Students feel that they are helped, but actually this feeling help does not mean that they learning more. Questions?
I think we have already one question.
First of all, thank you for your presentation. I slightly touched this subject in my presentation as well, so it's really interesting for me. Do you or the university in general plan to teach the students how to learn and work alongside AI?
Very good question. Should we? We should ask you, should we teach students and what exactly? Because I still think that this basic knowledge, what is loop or what is class and what is abstract class should be, because without this, students will not be able to check this code. So we still should teach this, but after this, what exactly students should have to know?
What I have in mind is that the students, or actually like everybody who use AI for their work or for whatever, I think there's an issue that people just consume the outputs of AI without learning from it. Yes. So this is something that I would actually expect the universities to adapt to, because AI is not going anywhere.
Yes, of course.
People will use AI. Yeah. I'm practically giving my presentation already, so yeah, this is something that I would like to see when the students finish their universities and they come working with us, so they don't just consume AI like it's fast food, you know.
Yes, definitely.
Yeah. Okay. Thanks.
We will work on this.
Yeah.
Thank you for the presentation, Marina. It was wonderful. And I actually have a similar question also. So I was just started my master's in software engineering also here in Tartu. And actually in some courses, as everything is like, there's tons of material and you need to know everything, it's actually a bit recommended to use some of it. But I actually thought like whether the university or specifically the computer science faculty has thought about creating this safeguarded or guardrail like model where you can just ask for assistance for not with the code but actually with some theory or just for the explanation part, and it would like maximum give just some pseudo code for the assistance, so it would be more understandable for students that struggle with actually just struggle with heavy theoretical parts?
We have some students working on this. I have one PhD student who is working on this teaching assistant AI. It would be AITA, like AI teaching assistant. In Estonian, AITA is very good name. But it takes time. We cannot like force every teacher to use this or to provide. We have every teacher can select there, but we can think our institute can think that what will be our policy and for this. It would be nice if, for example, for our schools we have this AI Lepp, but they are not doing anything for universities. It would be very good if the country or the government would provide AI Lepp for universities as well.
All right. I think this is indeed a quite interesting topic that we might even continue in the panel or even later in the networking afterwards. I think we should now stop with the presentation part before the coffee break. So thank you again, Marina. But before we all leave the room, we have one announcement to make. So Mariana, you will please come to the stage and make your announcement about our... You can take this microphone. Oh, you have one. Ah, sorry. Okay.
Hi, guys. My name is Mariana. And thank you, Dietmar, for allowing me these few minutes to introduce you to Digilink, a program that connects companies with the future IT talent. So Digilink is an 11-month-long collaboration between final year master students, partner organizations, and the Institute. And it can result in practical solutions, innovation, and even give the companies a competitive advantage. Why should all companies think about participating in Digilink? You will have access to undiscovered talent. You get the student. And the student will have academic supervisor, so you will also have access to established expertise. The student will use university methods to solve or approach your challenges, and therefore you will have challenge-based problem solving. And of course, you'll have a chance to strengthen your organization, employer branding. You can show yourself as an organization that invests in talent. So the students who will be applying to the program are master students who will be graduating in June 2027. And I will not go through the list that you can see here, but I've listed some of the key specialization areas of our curriculum. So you can see that all companies who use data or deal with cybersecurity, use any sort of IT systems, can find or can benefit from participating in this program. And you can see also some of the companies that have submitted positions previously. We have had IT companies such as Veriff and Bolt. We have had classical manufacturing companies. This year we have Medtech and GPV Estonia. We also have public sector, Päästeamet or the National Rescue Agency Board. We also have small companies like Maidelo and huge corporations like Swedbank and SEB. So every company can find something. What I want you to take away from these 2 minutes I've spoken to you, the program lasts for 11 months, August 2026 to June 2027. The student will commit to the program for approximately 3 days a week. The company will receive a monthly invoice from the university, but most of the money will go to the student as a scholarship, which means that the company itself does not have to pay a salary or anything else in addition. And of course, partners get to choose the students they work with. If a partner does not find a suitable student, then they don't have to take one. And how to join? You can join by submitting the description of the position where the students will apply for by February 6. If the deadline scares you, but you're really, really, really interested in participating, you can send me an email and I'll see what we can do. And you can read more about the program from our website by scanning the QR code. Thank you.
Thank you very much. And I think that brings us now to the coffee break. The coffee is outside, but we have still some talks We start at 6 o'clock sharp, so please come back at 6 o'clock. All right, I think it's time to continue our seminar, AI for Software Engineering. And our next speaker will be Hanna Tagen from IndiGO. So please, floor is yours.
Survive or not survive? That's the question. Finding balance in AI-assisted software engineering. Hi, I'm Hanna. I'm the head of ADS software engineering, and I'm a little nervous because I haven't publicly spoken since university, so please bear with me. Thank you. Anyway, I work at IndiGO Technologies, where we quite literally are reinventing the wheel, building next generation EVs and AVs. This means that our company and all of our work is extremely safety critical. And this makes AI-assisted engineering partly dangerous, and in worst case scenarios, even fatal. So building things fast is good, but building things fast and wrong should be avoided. Okay, so where did we start? About 2 years ago, I started working with our legal team to put together AI policy for our company. The first question was, of course, the very fundamental one: should we even allow AI usage in our company? We saw a lot of companies banning it altogether. But we decided to opt for the balance and allow using it, but with clear guardrails. So, the main issue here is, if companies ban using AI, it doesn't eliminate the AI usage. It just eliminates visibility and control. And this is why we allow using it. So our adoption began very organically. It came from bottom up, not top down. And we started basically from the software engineers starting to test it out to see just how smart it is. Now, AI has been quite embedded into our workflows, into our company, into our culture, and so forth. But since our industry is extremely safety critical, our usage of it is more safe. We use the more safe approach, basically. So, okay, so how do we use AI today? Basically, we do use it within the whole software lifecycle, but it's in the safe side, as I mentioned. So requirement analysis, we just like to use it for helping us summarize long stakeholder text or analyze standards, which is extremely information packed and so forth. We generate reports, documentations, and use cases, user stories, and so on. Architecture and design and development are the areas where we use AI the least. We don't use currently any AI coding assistants. This is because, as I mentioned, the safety criticality and so forth, we can't let AI write our code if it's going to kill someone. It's harsh, I'm sorry, but it's true. And we don't let it, and we don't allow code reviews being done by AI as well. And I don't see us getting to this in the near future. Where we do use it the most is basically the requirement analysis and testing side. And for testing, again, we don't use AI I mean, we don't let AI to make pass or fail decisions, but we use the help from AI to help us maybe perhaps like see what we have missed or generate new testing ideas. But in the end, AI does not work the best for us due to our industry. And I'm going to talk about this a bit later. Now, I actually have a second part here, which is the management part and the learning part and the regulation part, which is not directly related to software engineering, but it's indirectly related. And this is something that goes really to my heart. But I think I'm going to skip this because I think I don't have time for this. I'm gonna save it for next time if my memory might get back. Anyway, but mainly management. I use AI for discussions for people management, project management, learning soft skills, hard skills, and regulate myself because I'm a human and I get triggered. But my goal is that I'm not gonna let my triggers affect my team. Anyway, what are the benefits? Faster iteration, and it doesn't mean delivery, but faster iterations in the sense that we get to the very first draft, very first version faster, and this really kicks off the whole project for us. Level playing field. This is kind of a contradictory one because in some sense, as Artem, as you mentioned, it's kind of like how did you say that? It was learning wheels, I think, yeah? It's kind of like learning wheels for the junior developers. So in that sense, it does level the playing field for the whole engineering department. At the same time, it does increase the gap between junior developers and senior developers, or weak developers and strong developers, whatever way we're going to put it. Knowledge sharing. This is kind of related to the previous talk. This is what I mean by knowledge sharing is that when I use AI, I always tend to think, is this something that others struggle with as well, or is it only me? And if the answer is yes, that it should be shared by anybody else, then I tend to share the knowledge immediately. So it's basically if you are all in this lecture hall and I'm AI and I'm standing on the door and all of you are exiting the hall and every single person you are going to ask me, hey AI, where's toilet? And I'm like, that's an amazing question. And I'm going to point to the toilet. So it's easier if the first person asked the question, and after that, I'm just going to put up the sign. So same goes for everything in engineering as well. So if the first engineer struggles with some issue or falls into a trap, then they should investigate it, learn from it, and share the knowledge. And support systems, this is, again, related to the management side. We use AI to help us with project management, task management, all kinds of administrative tasks and so forth. I have to mention here that we don't use agentic AI anywhere, and we're probably not going to go that way anyway ever soon. Okay, what are the challenges? Trust and verification, the first one, which is quite generic one. I mean, I think everybody has it. But I must say that I don't have much issue with AI being wrong sometimes. We can get wrong answers from anywhere. I can ask my colleague and they might be wrong. I can ask my teacher and they might be wrong. I had once a teacher in my middle school that unfortunately taught us all the wrong math equation. So mistakes can happen anywhere. And it's all on us to verify that we have the correct information. Tools and practices. For me, the biggest challenge is that when I start to use one AI tool, and in the middle of it, I find that another tool might be more useful, then I have to start the whole process again. If the sky would be the limit, all the AI tools would be integrated, and I could just swap between the tools without losing context and the grounding I have already created. It's basically similar to the Apple ecosystem where I can just pick up my work on any other device. Skill issue. This is now the part that goes to the last presentation. I think that using not ChatGPT, but using AI has become a skill issue. So paradoxically, AI gives the best results to people who already know the domain and who already know the problem deeply. And prompting is a skill. So this is something to perhaps the university should think about as well. Another thing is that skill issue causes the consistency issue as well. So I can ask AI something, and my colleague can ask AI something, and there comes an issue with the prompting and with the grounding and the context, that it can give us basically a nonsense answer or a very good answer. So it's the consistency is an issue as well. I'm going to skip the ethical, legal, and policy because that's a given. I think the most important one here is the industry constraints. I work in automotive industry. And this means that it's less publicly documented, meaning that the model doesn't have as much as information to learn on. And it doesn't give us always the correct answers based on this. It can be too vague, it can be partly incorrect even. And this is something that, especially in our industry, we have to really keep an eye on. And this means that AI does not minimize engineers' expertise. If anything, it demands more of it, because we have to verify that it's giving us the correct output. Okay, so what do we expect from the future? I already mentioned this with my question. So from the future engineers, I hope that the university and all the education, academies and so forth, think about how to teach the students how to learn with AI. So AI is here to stay, basically. How do you make it so that you don't just consume AI as a fast food? You should consume it and learn from it and share it and integrate it into your brain and so forth. So just don't just consume it. And there's all of these three parts are actually connected. So the strong engineering fundamentals is again extremely important, because if we don't have the fundamentals, we can't verify the outputs. And the students have to also be with ambiguity and curiosity, because as I mentioned, AI, and as you all know, basically AI is here to stay, but for our industry, there might be a case, maybe tomorrow, a new risk arises, and I don't know, a regulator bans AI in this industry. So we have to have the fundamentals in place so that we don't sink and swim, basically. Engineers should have the ability to swim. You don't want to put a person who doesn't know to swim on a speedboat that sinks in the middle of the sea. So this is something to think about. Yeah, so are you vibing? We are vibing. Yeah, thank you.
Thank you. I do have a question, but if somebody from the audience wants to ask, then please go first. No? Then maybe then I...
Yeah, thank you, Hanna. Very good presentation. My question is as such that you are here in the European car industry company thinking about ethics and safety. And on the other side of Atlantic Ocean, there is Tesla, which you have to exist on the same market as them. How will you stay afloat? And it's not only Tesla. I mean, in between, there is probably a spectrum of companies, but not all of them use AI responsibly.
Okay, so first of all, this is actually a US-based company. So we do have to account in both US and European regulations, and we can't miss any of them. Did that answer your question?
Yeah.
Maybe then I do have really, my question is in a way related to what you were asking. And you somehow mentioned at some point in your presentation that you do use it in engineering, like for testing, but then you said also maybe not. So I just wanted to ask again, do you use it for at least some aspects?
We use it for helping us generate test plans, but we don't use it for unit tests or we don't let the AI decide what we test.
Right.
We just basically it's a sparring partner for us.
Okay.
So I'm just bouncing off ideas. What did I miss? Did I miss anything?
Okay, okay. No, that's what I was actually expecting that you do that. I was just wondering.
Because I think in automotive industry, don't see it happening that we're letting AI testing our code.
Well, I mean, you can at least generate test cases, yes.
Yeah, but we have to validate.
Yeah, but then you... Yeah. Okay, fine. Thanks. Yeah. I have questions later offline. Okay, yes, there's one.
It's kind of a naive question. Is it possible to use vibing to kind of generate something and then see, rather than have it test, to have it generate something in your case, and then test it separately, either by hand or by AI again, if you understand. So rather than have it to test to create new ideas.
I'm not sure.
Of course, it's possible, but what do you think of the idea?
Can you rephrase it?
So basically, it's like you're going to code something, and then you're testing it, and then you might not be happy, or then you think about could it be done differently, or you basically you don't know how to start. You have different alternatives. So then you could kind of innocently ask AI that you have any suggestions, without dedicating to following AI.
Yeah, this we do actually in some cases. So some of our developers use AI, but there are others who don't use it at all. So we don't force it on anyone. But we do that in some cases. So it's possible, but in the end, it's basically, we use it more for the first versions and first drafts to just get the ball rolling, Yeah.
All right, thank you. I think we stop here. Thank you very much.
Thank you.
And have our next speaker, Toomas. Römer, please come up.
Hi, everyone. My name is Tom, and I'm from Bolt. I probably have the most generic title. I went through the abstract of the seminar, and then I came up with a title that would actually cover the parts that the seminar said it will. But I did add the other part there, so it won't only be about software development lifecycle. I'm actually an alumni of this university. I Googled for it. I finished 16 years ago. I've been working in software development over 20 years and also at Bolt over 6 years. And all of this new coding tools have enabled me personally also to play again. So I used to code a lot when I was younger. I've been on the management train for the past 10 plus years. So I have coded, but all my projects, they kind of never finish. So I've finished quite many projects in the past couple of months. But coming back to the software development lifecycle, I chose the first 5 that came to mind, and the 6th was when I consulted AI. And I think these are the most classical ones also taught here. It starts with product requirements. There's design, development, testing, deployment, maintenance. And quick spoiler, like all of them are changing. So no question about that. Some context, or actually I'll have a couple of slides about context. ChatGPT launched, or like general availability 2022. Something I call here dev hype. This is, let's say, the software development related hype, or fear of missing out. I started feeling it 23, 24. And of course, over the time, I personally tried, others tried, and it didn't deliver on the promises. So usually the answer there was like, hey, don't focus what it does today, but think about the future. Then I think there was a huge step up about a year ago that can be tied to the updates from Cursor. And another big one was just a couple of months ago. Here I have December because this is where I kind of saw it personally. When you check when this new Sonnet and Opus models came out, it's more like November. But if you check the Cloud Code, the repository for the new skills and plugins, etc., then that's more like a December timeframe. Also, another part of context is that there has been like, here I have 1.5 years. Probably it could be 2, it could be 1 a period of this hype, and the failures from the experimentation have caused a lot of overall fatigue when it comes to trying out new tools. So about Bolt, the tech organization is about 900 people. Out of that, 600 is engineering, 300 product. We have multiple products. You've probably seen 2 apps, but there's other apps. There are lots of web apps, so let's say 20 plus. But most of our backend is a single technology, so stuff should be easy. And we also have a lot of product delivery plans constantly, so any kind of experimentation, this is always kind of a little bit expensive. Our overall take is that if we take software developers, it's fine to have multiple tools, multiple coding tools here, I mean. So when I mentioned this February 25, then until that moment, there was a huge push for using coding tools. I think Copilot was the most famous one there, but we can say Copilot, but once you go in, you can see that it has access to so many models. Today, probably the list has 20. So you say Copilot, but it could be using any kind of model that's out there. Since February, it has been a very natural pull from developers. So we hit about 100% utilization probably summer. And now it's, as we have multiple tools, then it's over 100%. I'm not sure if it's 200. For generic tools, ChatGPT, Claude AI, Gemini, similar, you can also have multiple tools. I think like overall we're in this phase of experimentation where we don't know which tool is right. We rather spend the extra money to find out better use cases. And for non-engineers, it's also fine to have coding tools. And right now we're working hard on enabling non-devs to host their solutions in a secure manner and let's say safe environment. Over the past year, we've had to speed up tool evaluation cycle a lot because there are so many tools to check out. At the same time, you don't want to spend too much time on them, so it's a little bit catch-22 there, but we've taken conscious steps to decrease the cycle there. Over this period, whether it's from the push or pull period, we've made sure that the minimum is done, tool availability being one, tool adoption. Tool adoption was interesting because last year it also a little bit felt like a witch hunt because we weren't so much looking for to get our adoption up, but we were looking for people who weren't users to ask like, hey, what's up? Because we've seen so many gains in those tools, then it did resemble a little bit a witch hunt at one point. Then making sure that all our repositories have the necessary configuration files, Claude agent, whichever the format for the respective coding helper. If there's an MCP, then let's get it installed, configured, and make sure that we update it because they kind of level up very quickly and it's not kind of install and forget, but rather iterate there also. And then we have a bunch of mini communities. Couple of channels is AI coding tools, AI general tools, AI productivity, etc., etc. Some are small communities, some are 1,500 people channels. Now we're getting back to the software development lifecycle. I think my overall idea here is that everything is getting compressed and also blurred. So whichever term the result is kind of like the same. Here I've outlined only the first four, but only because this is where we see it the most. And even before we dwell in on these, if you take a smaller company, then everything is getting blurred, especially like a one-man startup, 3 people company, 5 people company, like whether it's a software developer, a legal person, somebody else, they could be doing product development, customer support, compliance, finance, all in the same day. Like when I was younger and then we needed, let's say, legal help or some sort of help that we didn't have in-house, well, you had to get a consultant, you had to phone somebody up, ask a question, maybe get a deal with them, get a NDA, negotiate some sort of a remuneration there. So now if you want a new end-user license agreement or any kind of legal work done, which isn't something like super important, then it's a couple of minutes away from a final version. So smaller companies, everything is getting blurred. Coming back to the software development lifecycle and this compression. If we zoom in on these particular elements, then the extreme change is like if traditionally there's a product manager writing the spec, designer designs, developer implements, there's QA, and then there's loop is going on. Then in the extreme case, it's kind of like one person describes intent, what they want to do, and then they kind of refine and iterate with a AI. This is kind of like a very, very extreme case. In our case, I'll actually zoom in a little bit more, but overall it's that everyone can prototype, design, write code, test. It's not so literal that we have product managers writing tests, but if somebody has an idea and wants to prototype a solution, then again, it's like 8 minutes away from some sort of a quick prototype demo, throwaway prototype. Or another important part is with these tools you can install all kinds of kind of quality gates. Here, if there's a document and there are document handoffs and I don't know, certain people have certain issues in their documents, they can just make sure that before they share, they consult their agent. Or at Bolt we have a very particular way how to write stuff, which is kind of similar to what Amazon coined. So if we take ChatGPT, there's a separate prompted GPT for writing in Bolt style. And overall, like all phases improve, and then you don't have to go to the extreme case. If we think of the results of the compression, like the obvious one is efficiency gains. If there's less handoff time friction in those phases, you'll win time. That's usually the reason. Like I think our seed for motivation is we're in a low margin business, and then we have heavy competition, so it's all about speed. So when Priit was talking about the seed, then we're mainly from the efficiency world. But at the same time, roles change, like generalists become more needed, and the titles blur there. Quality risks go up, which is kind of like interesting. These are like very obvious reasons. If you take this each phase done by somebody who's more of a generalist, then you'll just have less scrutiny there, and you just get new type of bugs. So instead of like logical bugs, you might have a hallucination bug. If you think of technical depth, and you've been in the industry for a while, then you think you've seen all kinds of technical depth, but now we have a new type of technical depth with this possibly huge amounts of code that's being deployed and or being pushed and accepted into the code base. Of course, you should be fighting against it, but some will get through. And it's probably more difficult to reason about certain things because sure, you can have the best policies in place, like, hey, review the code, the person is responsible, yada, yada, yada. But in the end, in reality, you will have issues with code that you might not be able to reason about. And of course, org changes, non-engineers entering the building process. So if I think particularly about Bolt, then, and I think about efficiency gains, and that's a question that's very, very often asked, like, do you have proof points about efficiency gains? And this is something that I also ask whenever I meet other people. And the quick answer is that we don't have this holy grail saying that this has gone up that much, because projects at different phases get a very different type of benefit. We're quite optimistic that we can sense the gains. We also use kind of engineering analytics. We employ this Swarmia. There aren't any particular metrics, DORA metrics, number of pull requests or anything that I can quote here, like, hey, by using AI to this extent, you're going to get this. But the belief is quite strong. But just a reminder that in the past there also, I mentioned two phases where the quality of the agents went up a lot. Role changes, we don't see that much. This defining and applying quality gates, that we see, whichever phase you pick. Quality risks, so we have definitely seen that AI slop has entered the building. It's you can see it on Slack and in documents. So we're also kind of actively trying to fight against that. People have started writing in very interesting ways. And non-engineers have entered the building. I put them into two buckets. One of them, I call them techies. They're building kind of highly sophisticated workflows in a very controlled, low-code system. I've personally been very impressed about certain workflows there. Like the workflow, let's say, fits on the screen. There's, let's say, 25 points there. But as it calls into so many integrations, multiple LLM calls, then the end result can be like, wow. Then the other part is non-tech is writing code, and for there it's more of a distribution and a data problem. Cool solutions require data. If you have important data, you don't want to give that data out without controls. But more than that, it's distribution. If somebody coded something up that's helping them in their day-to-day operations, then ideally we would want to have an internal system with a single sign-on, VPN, all kinds of stuff, and that they can make them available to other colleagues. So I guess the conclusion is that in the beginning I said don't focus on today's results was very often what you got 2 years ago or a year and a half ago. Then for me personally, the promised future is here already today. So I'm a little bit scared what's coming. And overall, I think it also has been quite many years of fear of missing out. Constantly people sharing stories how they did something crazy with AI, and then very often then finding out it's not true or half true or very far from truth. Then it has been like mentally draining, but everything is changing. So as it's not going away, so it's kind of like embrace the change and then try to live with the FOMO at the same time. Any questions?
Thank you very much.
Hey, thanks for your talk. Maybe even 2 questions. The first one, have you tried in your company the Claude bot, recently renamed to Maltbot, to not be mistaken with Claude, or recently introduced Claude Co-work, which introduces the agents that can do work for you overnight, for example, without the need for you to look after it. Have you tried this thing?
The first one I haven't, but I think there's an interesting post how it retains memory that came out yesterday, which is kind of cool. But I haven't tried it myself. I have. Anyways, I'll take the next question. That was Claude Co-work, or that was?
Well, from Claude, it's Claude Co-work,
yeah.
And there is an open source Maltbot.
Yeah, Claude Co-work. When it came out, I had this. I tried it on the first day, but I just haven't been able to find use cases for it because I like my terminal. So Claude Code is very similar to Claude Co-work. If you're non-techy, then probably giving access to local files, having, let's say, some sort of your defined memory there, I think it's a great tool. So whenever I talk to ChatGPT and I'm thinking like, I wish there was a file where I have control that retains the memory of the conversation and then I can kind of swipe the context and everything. I would love that. So that's probably Claude Code equivalent or like this Claude Co-work. But yeah, I mean, very often I have projects in a folder. It has kind of a memory file. I chat with it, and then when I want it to persist something, then it persists. And when I come back, I continue actually from that file, and I kind of control what's there. I delete stuff that I don't want to be there. So it's kind of like a simpler version of this difficult to pronounce, but this Claude bot, which is pronounced as CLAWD.
Yeah, thanks. And the second question is, how unified are you in your company with regards to GenAI? Like, do you have some setback from security who says, oh, you send all our code base to ChatGPT and Claude and they have access to it and we don't want this?
How was the beginning of the question?
Like, is the whole company, yes, let's go and vibe code and do this, or do you have counter forces that fight against this and say, we don't want these security problems or we don't like this at all?
I think the counter ones, I think the resistance is underground, at least not visible. But overall, like, I don't know the stats today, but if we take this pre-GenAI period, then we were doing roughly 600-700 releases a week. So to make sure that the quality is there, whether security or just availability and all kinds of issues, then you have to have a lot of like safety nets. We haven't particularly introduced too many more safety nets because of GenAI, but they have anyways evolved over time. So I don't have this worry, or I also don't see that we have so much more code now flowing through. So do you need to update the process? Definitely. I want to believe that's also, as the adoption is evolutionary, I think that can also be evolutionary.
You mentioned that your company works on scale and low margins, right? So how fast is the cloud bill picking up and the actual compute cost? And how does it eat out the margin?
I think like overall, if you take a single ride, then it's minuscule. But the pressure that we put on overall cloud spend is a lot because it's straight money out of pocket. So I think our efficiency metrics are good. If I think cost per 1,000 orders or similar, but in absolute numbers, they're humongous. Yeah.
A question about humans kind of picking up all the changes fast enough. Like as the technology changes so fast, there is a lot to learn every day. Do you see more and more time also for many employees, not just yourself, that need to spend more time learning?
Yeah, like if we think of overall experimentation, then we have also a couple of programs going on to give people more time for that. We haven't gone that extreme, but I was talking to a CPO of a company that had 2,500 developers. And 2 years ago, the whole company took 1 month off in the sense that they experimented with AI tools on a day-to-day, and they didn't have the delivery kind of metrics monitored. Then last year, they only did that for tech. So we haven't done anything that extreme. But this year, we already will have a couple of programs for that. But yeah, it's plus everything is changing so fast, so that's a tough one.
So I have a comment on the question. The comment is about the efficiency gains, and when GitHub Copilot first came, we tried to measure that actively, and the feedback that we got from engineers was that yes, it feels faster, and I wasn't sure if it actually was faster or it was more enjoyable to work in that way. Either way, if it was more enjoyable to work in that way, it's also a benefit that we should consider, because that makes us as a better employer and better place to work in for engineers. So it doesn't always have to be like 20% faster. It can be that it feels nicer to work this way.
I've also heard that, and the people have said that at the end of the day, their cognitive load is kind of lower because they haven't had to crunch so much in their head. And the other part is if we think of developer happiness, then it has been shown in so many places that overall it's a proxy method for higher efficiency, like this developer experience results, etc. So I definitely support both of the ideas there.
And the question kind of relates with what Hanna was talking about, that the engineers need to be able to essentially work without AI as well. They need to have the capability. And there's a lot of news about or fear about when the investments for these AI tools run out, so they need to increase their prices significantly. So how are you mitigating that risk that all of these tools that the company uses suddenly have significant price hike?
I think the rate of people going dumb and the rate of the price hike, like I think we won't see it hit so hard like anytime soon. So and then if we think generationally, then of course we're we're in a bad spot. Or something very depressing that I said last week somewhere was that if right now we're buying tokens from silicon, at the same time we're buying tokens from, let's say, organic matter, then the silicon tokens are very cheap. but that might change in terms of like they just get so much better that the organic ones are too expensive. But that's a very depressing future. So thank you.
All right. Okay, yeah, one last, and then I think, well, anyways, we are eating into the time for the panel. We make the panel super short then, but let's have this one question.
Thank you. Luckily, it is a short one. When you're doing your small projects, playing around, which models do you prefer?
I've been like really surprised how much I'm personally a bottleneck. So there was one weekend where I was using Claude Code. Probably I had back then Sonnet something, working on one project. I was building an Android app that a relative of mine asked me for during Christmas dinner. Anyways, next day I was coding that. Then I was coding a Chrome plugin. I think that was also in Claude. And in anti-gravity, I was working on, I think, some Java. So I've been trying them all, but if I want to do something in a way where I feel like very productive, then this Opus and then the Claude, this Max, because from the Pro tier, I usually run out in 45 minutes. Max, I think 3-4 hours. I get tired before he does.
Thank you.
Yeah.
Thank you very much.
Yeah, I linked to 2 Twitter accounts. Like they write very good stuff about programming realities from sources that I trust.
But by the way, that's a good point. Do we get the slides, and will they be made available afterwards? What is the... So even the video, but okay, because indeed, I mean, okay, good. Right. Okay, so thank you very much. Since I do not really want to go much over time, but maybe it's still okay for the panelists to just come up and we have a sort of stand-up meeting. We don't need to move chairs and stuff. Just let's have a very brief final conversation. Because there's one thing I mentioned earlier that I would like to ask everyone, okay, maybe almost everyone, because Marina is a bit special case. No, it's up to you. I mean, but the question to the representatives from industry is, what would you say is, from a software engineering point of view, the area of research that we at the university should focus on?
Actually, something you mentioned, the impact on cognitive load is an interesting one, because it kind of feels easier, but just during the break we had a discussion that now it requires different type of cognitive load, a different type of thinking. You need more critical thinking to validate what's coming out of, rather than creative thinking of you building something. So it kind of feels lighter, but maybe that's because we're not thinking as hard critically about the things that come out, and we're just trusting too much. But about this, how it affects cognitive load and maybe even long-term studies would be interesting.
Yes, good question. Thank you. I believe we need better tooling, because currently, of course, AI has been first generations of AI have been trained on human software engineers data set. And of course, it's kind of a loop where we now have AI assistant developers, and the new models are training on kind of their output. But still, if we look at the tools, we can already see that the terminal tools are more productive than GUI tools because, of course, terminal is text-based, but the terminal tools we have are still kind of human-focused and human-oriented. And for instance, they're very precise. CLI tools are very precise in what flags they take, and maybe this is one area of research. Then, for instance, for web use and browser use, kind of the most productive approach we see is either kind of pasting screenshots into LLMs, which they can have to be multimodally analyzed, or some kind of Selenium-powered frameworks. All of this seems to me like a very much over-engineered bicycle approach. If a native way for an LLM to access and serve web is created, then it would be very helpful for this kind of engineering.
I think it's the same thing that actually I commented on Marina's presentation as well. So I think the universities should research how to teach the students to learn with AI. So I think this is really important because AI is here to stay, and people will use AI. But using it, as your notes also said, that it makes, even the students say it themselves, that it makes the brain lazy. So how can we alleviate this? How can we learn with AI and not have that lazy brain, basically? So I think it's kind of like the issue with the calculator.
But that's not software engineering, right? That's maybe psychology.
Yeah. But I mean, it's tied to the software engineering. But if you ask me about software engineering, then I also have the issue that our industry is not that well presented in AI. So that's something that maybe you can research as well.
I have one comment to it. For any students currently thinking about the thesis topics or research topics, you know the field of human-computer interface, right? Where the best interface is research. Consider the emerging fields of computer-computer interface, or well, that's just APIs, right? But not quite. And computer-human interface, when the computer is the one driving the interaction, the agent one. Yes.
Well, I don't have a very good answer there, but I started thinking from two angles. Like one angle is that if the evolvement in overall machine learning kind of came from compute coming to an age where you can do all of those like crazy stuff, then what are the other parts that were behind compute? And I have no idea what those are. But the other part is what I'm happy about is when kind of DeepSeek entered, or all of those players that are kind of making it available for, let's say, not almost everyone, so that it's not just a couple of big players having a secret tech. So this is where academia either reproducing something similar whenever they see something in the industry has huge value, rather than these things being at the ownership of just a few large corporations.
All right. So maybe, because we have only 5 minutes, so maybe we can have one or perhaps two questions from the audience, but I would like you to think of a question that is really meant for everybody standing here, so that everyone can maybe answer with 1 or 2 sentences. Do you have anything that you say, okay, what do you suggest? What do you think about this? Yes, there's.
Yeah, so my question is fairly simple. I'm just thinking how can I structure it quickly. Do you think that the general usage of AI, when juniors programmers and middle programmers use generative AI, do you think that it will somehow resolve in the future where we don't have like genuinely good engineers? Because in my day-to-day work, I get to review juniors and middles, and I see that they use AI very often. And I see this kind of problem that they struggle to understand how to structure systems and how to write genuinely good code.
Okay, now I make it like a journalist. Please answer in 1 or 2 sentences.
Most definitely, and the further you go in the future, it will be just as bad as the crowd here being able to write assembler.
Most definitely, but the question becomes how fast can we correct for that? Because there's always going to be good engineers who need to teach these juniors what these principles and practices are that need to be followed. So the correction is already happening, but is it fast enough? We don't know.
Today we have embedded engineering and software engineering. Tomorrow we'll have embedded software and AI engineering higher level.
That's very interesting comment. First of all, yeah, definitely. But at the same time, this is exactly why I added the comment to the last, like the research question. So this is actually software engineering related, because learning to learn software engineering with AI is a bit different than learning from AI to grow tomatoes.
I should agree with everyone. Just I believe them.
Okay, so then let me. I think it's time now to conclude here. Time is over. Thank you very much once again for all the participants. Thank you everybody for coming here. And now I think we have only a small announcement. Oh yeah, maybe we can have the hand clapping now, and then. And then we have one announcement, a last one without talking. We have another data science seminar coming up on health data, March 18th. Please keep a note in your calendars. You will get anyways announcements about this. Okay, thank you.